all quality of service does in the wireless space is, if you remember that the way a client talks, right, is a client, if my PC needs to send some data, then it's going to pick this number known as a AC win min, basically. In other words, it's going to randomly pick this number, it's going to start counting down. And as it's counting down, it's listening to see if anybody else is talking. When you have a higher quality of service, that number that it takes to count down is just a smaller number. That's really all it's doing with it, which means that if I have a smaller number to count down, then I should have more access to the media, the wireless media. But if my wireless media is congested for whatever reason, then having a smaller number doesn't do anything for me. So quality of service is good, but if I've got congestion going on, it's not going to help me any. All right. It also gives me my RSSI and SFR values. It tells me what security is I'm using. It also gives me packets and packet error rates, so the retries. And so when we look at things such as packet retries, if I'm having a lot of packet retries, then what that's telling me is that I've got a very high utilization. Either I've got a lot of noise in the area, or I've got a lot of clients in the area, to a point to where when I try to send something, I can't send it because somebody else is talking or because there's noise and I can't send it. So I'm having to basically queue it and wait and try to send it again. And then I try to send it again, and if somebody else is talking, then I have to queue it and I have to wait and try to send it again. All right. And so if we start seeing a lot of these packet retries start going up, that tells me that we've got issues, within the spectrum of whether it be too many clients or noise or interference, right? So we're going to look at that. Debug client, that is going to be, we're going to use it throughout this whole thing. It tells us a lot of information. And so it is I tell people the debug client is kind of like the go-to debug command, right? If you're looking for problems that's happening with association, authentication, DHCP learning, web auth type, all that can be seen within the debug client command. All right, and so we can look at a specific client that's there. Now, here's where you have to start kind of understanding what goes on where, right? So when we think about what handles what responsibility is done where, anything that is real time is handled at the AP. So probe request, probe response, all that type of information, beacons, things like that is all handled at the AP. Well, the WLC really doesn't kick in until we start talking about association type level stuff, right? So whether it be 802 authentication that happens, and then association that happens, and then 802.1x type of authentication, then we get into our DHCP learning, and then we get into the run state. The reason why I bring that up is because it's possible that you could go to, let's say somebody could call in and maybe they've got an issue, right? And they say, I can't connect. And you go and you say, okay, you go to the WLC and you run a debug client command, and you give it the MAC address of the device, and you say, okay, try to connect up now. And we're looking for these debug commands to come up. And they say, okay, I tried, and you don't see anything. If they're probing with wrong SSIDs, you would never see that in a debug client command, because the probe and the probe responses, or if anything's happening where the AP is ignoring the probe for whatever reason, you would never see that in a debug client command. because all the probe stuff is being handled by the AP. Now, what I can do is I will give you guys a command a little bit later on that will allow you to see probe aggregation on the WLC. In other words, what happens is the AP will aggregate probes as they come in, and then they will send them to Muhammad. Which part, Muhammad? Muhammad asked me to repeat the last part. The thing is, the AP does not send every probe that comes into it to the WLC. What it does is it aggregates the probes, and then we'll send an aggregation of the probes to the WLC. And so you won't see, when we do a debug client command, you're not going to see probe type information in that command. You're going to see what you're going to start with on a debug client command would be the 802.11 authentication, and then association, and then .1x type authentication, and then DHCP learning, and then run state. But you won't see probe information in it. There is a command I'll give you guys where you can see the aggregation of probes on the WLC. And then there's also a command where you can actually see the real-time probes coming in from the AP if you want to go look at the probes.
But didn't you say you would not see those debugs if you are roaming? Is that what you said?
No. If you're not, it has nothing to do with roaming, probing.
Oh, okay, I'm missing it. Okay.
Yeah, if you're roaming, you will see roaming information on that debug command. All right, so we'll look at the debug client command. We're also going to see there is a link test. So, and just kind of give you guys an idea here. Let's do, let's see what I can do. Let's close this. And I'm going to come over and so I'm connected there. So in the WLC, I can see my clients that are connected to. And if I come over to the little, they call this a chevron, so anytime you see these little blue drop downs, they call them chevrons. And the thing is, they're actually hover over, so if you've ever dealt in WLC, the first time you do this, for about the first 5 times, it's a pain in the butt because everybody goes over and clicks on this thing, and it always, when you do it, it only clicks on the first thing, which a lot of times is delete or remove. But you'll notice that I can come over and hover, and I can do a link test here. And it's going to go out, it's going to come back, and it will give me a link test to that client. So it's going to tell me what the client MAC address is, what the AP MAC address is. And again, what I'm looking for here is things such as packets lost, right? Or packet retries. These retries, if I've got a lot of retries that's having to go to that client, then all of a sudden you might say, well, that tells me that the AP is having issues sending the packets, or I'm sending them, I'm not getting the acknowledgement packet, having to resend them. Therefore, I've probably got noise going on in my area. Something going on that's causing me to have that problem, right? But what we're also looking at is things such as the RSSI value and the RSSI value at the AP and client and the SNR value. So how good are these, how good are my values here, right? So this is where you're going to go back to this screen here, and you're going to say, okay, anything that is basically less than neg 62 is exceptional. Well, you'll notice here we're at our minimum is a neg 37. Right? Well, the reason why it's a neg 37 is because if you want to go and we've got these APs that are mounted on, and right beside them we've got these virtual machines that are So you're normally not going to see that in a environment necessarily. But anything I think you guys was 35 or better was set there. So this is one place, and this is real time information where I'm doing a leak test. I'm getting that information on that leak test. So that's the leak test. Let's do a and I don't know if everybody knows this or not. I found some people do know you can do this. So I'm going to tell you guys. Some people don't know you or don't realize you can do this. One of the things, when we do these debug commands or these show commands, a lot of times they just scroll, right? And then we're trying to look at our PuTTY screen and try to figure out what's going on. It's much easier to look at it in a text editor. And one of the things you can do with PuTTY, a lot of people don't realize you can actually save a printable output to your desktop, which is much easier to look at. And if you have not done that before, just so you know, the way you do this is I actually opened up my session here, my IP address, went into logging, clicked on printable output, and then told it the name and where I want to save it. And then what's going to happen here is when I connect up, otherwise, you're trying to read these things, and they're a pain to read sometimes. So let's do a show font detail. And in the book, in the slide, it says details. It's actually detail instead of details. And I think the MAC address is B07F B9 47 B6 AE. Let's see if that's it. Yeah. All right. So let's do that, and then let's do a, let's just leave that there. So let me close this. And then you'll notice that it made my file here on my desktop, and I'm going to go ahead and open this up. And it's a lot easier to look at it this format than it is trying to scroll through PuTTY to look at it. And let's see. And this gives you a lot of good information. So, what I mentioned, we're looking for things like RSSI values, we're looking for SNR values, we're looking for things like supported rates. So especially when we get in, you start talking about performance issues, we're looking for, okay, how good is our connection from the client to the AP? And so I can come through here and I can say, okay, the username basically is T-Mobile that's here. Here's the SSID that they're connected to. Here's my BSSID that I've got. And if I start looking, the authentication algorithm is an open system. So the 802.11 is an open system. Here are my current rate. So it's the M8 SS2. So if you go to your, basically your MCS ratings and find M8, the SS2 actually means 2 spatial streams. And so you might have M8 SS1, M8 SS2, and then that's going to tell you what your theoretical data rate is. Remember, because we always talk about what we say the data rate is, and then what truly the data rate ends up being is about 50% of that because of everything we've got going on. So there are charts out there. You can go look up what M8 SS2 actually is for your current data rate. This shows me what my supported rates are. And thing scrolls too fast. It also shows me that we are using 802.1x and AES as our cipher, and this policy manager state. So we're going to talk about this policy manager state, but what we're always looking for is for this policy manager state to be in run mode. So run mode means we have passed everything, we associated, we authenticated, we got an IP address, and I can send traffic. All right. If at any point we didn't get all the way through that, then that's where we can start to see, okay, what state are we stopped in? Where are we hung at? That's there. It also tells me what VLAN I'm on. So here I've got my VLAN number. And then down here we start getting into client statistics such as, okay, how many bytes were sent, received, how many packets were sent, received, do we have any EAP request message failures? So we start getting into not authentication failures at the very beginning, but more of if I am having to change my key and the AP goes to the client to change a key and something's not right, we have a failure there, right? These are really good commands to give you a lot of information about the client itself. And you can see here's my nearby AP. So it's going to tell me what the APs are as close to this AP and what we're hearing on that. A couple more things and we'll take a break. Also, obviously, ping the client from something in the network. We can look at traffic stream metrics. If I can get it out. If we're dealing with voice calls, traffic stream metrics tells me basically how many packets sent, received, how many was dropped for that specific call. CAC, which is call admission control. CAC is what handles congestion. Okay, so what CAC does, CAC's responsibility is, let's say that so when they set up your wireless up, can actually go in and say, look, I only want 40% utilization for voice, which means that if at any point the utilization of that channel gets above 40%, it will start denying voice calls. And that's CAC's responsibility. So what CAC does is when a device gets ready to make a voice call, it sends the information to the AP. The AP sends it to the WLC, and CAC looks at it, Call Mission Control looks at it, and says, okay, do I have the resources available for this call to happen? Do I have the bandwidth available? And if I do, it allows the call to take place. If it's not, then what it will do is it will deny that call, and you will see basically on the phone, it'll say something like network busy is what you'll see. And most of the time when you see that means that, look, it's being denied by CAC because the utilization of the bandwidth wasn't good enough for it to make a call. And it's kind of like it's killing one for the good of all, right? So if I've got multiple people on calls, instead of CAC just allowing somebody else to connect up and degrading everybody's call, it just denies that person from connecting up so everybody else's calls can be of a higher quality. And then, of course, we can do everything from, on the AP, there's a show controller command, show controller D0 or D1, 0 being your 2.4 gigahertz, 1 being your 5 gigahertz frequency range. And it gives, what the show controller command does is it looks at information from a driver and firmware perspective of the AP. And it gets kind of hard to read sometimes. But it gives you everything from, hey, what is the channel and power levels? What are missed beacons? If you start seeing a bunch of, missed beacons, that means that we've got so much congestion in our network, in the wireless space, that the AP can't even send beacons out that's going out there. It gives us things such as client status. It gives us things such as authentications in process, radio resets, which is important. If you have clients that are dropping, let's say you get a call from a user and he says, look, I'm connecting up and I might stay connected for, I don't know, a certain amount of time, and then it's like I'm dropping off the network and then I'm reconnecting. One of the things you can always check is radio resets. Radio resets happen when a lot of times there are changes that are made either from a configuration standpoint. So if I go and make a change in the WLAN, then depending on what that change is, it will reset that WLAN. In other words, it resets the radio and people will drop off. If there are changes being made by RRM, so RRM is Radio Resource Management. And what Radio Resource Management does is it looks at the environment and it says, okay, do I need to change my channel because there's a lot of noise on this channel, or because I've got maybe another AP that's close to me that's on the same channel? Or am I hearing APs too loud and I need to decrease my power that's there? Anytime that happens, the radio will reset and clients will drop. And you can actually see that with the RRM information in Prime. So you can actually start seeing in Prime, hey, what's going on? How many channel changes have I got that's happening? To help you make a determination, is RRM doing something that's causing clients to drop that's out there? And then, of course, you can do capture packets over the air, and that allows us to look at everything from QoS markings to we can look at the beacons that are going back and forth to we can look at what's called radio tap headers. So tap headers is information that gets put into the frames of the wireless when the network adapter captures them. That would normally not be there, right? So in other words, if I'm capturing frames, I'm capturing like management frames, I'm capturing maybe acknowledgments, I'm capturing beacons that are going on. But this tap header is information like RSSI values or SNR values for that specific frame. And the adapter will actually take that information and stick it inside that frame, and it's called a tap header. So you can look at that type of information from a connectivity issue if you're doing capturing of packets. It's a lot easier now in the newer version of code to capture packets on a specific AP. And so there's a couple of things we can do. You can go to somewhere like Wireshark and you can buy a dongle, right? And you can put it in your laptop and use Wireshark, and you can capture wireless packets. You can do it through the command line if you wanted to. And the other way of doing it, which is a lot easier now, is in the newer codes. The newer codes have this new interface, and in this new interface, if I go to clients, let's see. I've got a client, so I'm going to open this client up. And I'm going to scroll down, and you'll notice that I've got this packet capture. And what I can actually tell it to do is I can tell it the AP, obviously it's got the AP in there that the client's connected to. I can tell it what I want to capture, what I want to filter, and then basically I'm going to give it the IP address of my FTP server. And I'm going to click Start. And so this replaces, if anybody's ever gone in and done the packet capture through the command line before, and you had to go through and put in all the commands. This is basically doing the same thing. It just replaces that, right? It's a much easier way of doing it. And what Cisco's doing is they're trying to take a lot of those commands of monitoring and troubleshooting, and they're trying to put it in this GUI in the WLC to make it easier for people to do, is what they're trying to do. Let's see, Mohammed says, do we reserve CU for voice calls? Hey, Mohammed, I don't know. I'm guessing if you guys are doing voice calls, then you're going to have, whoever set it up is going to have set CAC up in a way that is basically got a limit, right? It's saying, look, if there's a certain percentage of bandwidth that's being used, that it won't allow any more calls to be made.
But the APs would be used for voice and data both, right?
Well, it depends. So most people will have two different SSIDs on two different frequencies. In other words, most people will use 5 gigahertz for their voice and 2.4 for data. Otherwise, if you're using the same SSID and the same frequency, then yes, you're using both. And so at that point, what it says is, look, if the channel utilization gets above a certain percentage for everything, it will just not allow any voice calls to happen. And again, the reason why it does that is it's basically, the idea is that it's killing one for the good of everybody, right? In other words, we're not allowing this person to make a voice call so that we can preserve the quality of the other calls that are out there. And then last thing, and we're going to take a break here, is, if it is interference, there's some things we can do to look at interfering devices. So, for example, in the AP itself, or it's not an AP, in the WLC itself, on the monitoring tab, we've got this Cisco Clean Air. And provided clean air is cut on, so all the new APs have clean air in them, but you have to cut clean air on for it to work. But what clean air does is it tells me, based on whether it's 2.4 gigahertz or 5 gigahertz, what is my air quality, so how good is the air quality that's around it. It also gives me what are any interfering devices. Now, I can also see this in Prime. So I'll show you guys this in Prime. But the air quality report shows me my APs, what channel they're on, and what the average, the minimum, and how many interferers I've seen. So in other words, air quality goes on a value of 0 to 100, where 100 is really good, 0 is really bad, all right? If I've got interfering devices, it will pop up here. So there's an interfering device report that will show you a list of all of the interfering devices and the APs that's seeing those interfering devices. So I'll show you guys in Prime where you guys can see this, but we can always go here and say, okay, what's going on with the air quality in the area? I can also come down and look at any road devices, and I can say, okay, here are the MAC addresses of the road devices. This is the SSIDs that these road devices are on. And here is the channel that they're on. And right now, these are all basically unclassified. Right? So I haven't classified them as anything. And just keep in mind, a road device doesn't mean bad device. It just means that it's a device that's not being managed by our system, is what it means. All right, so let's stop there. One more thing, go back here, is you can always use something like Air Magnet, Ekahau, which are you can use Cisco Spectrum Analyzer to actually analyze the spectrum in the environment and look to see exactly what the noise is, what the interfering devices are, what's going on in that area that could be causing a high channel utilization. Let's do it. All right, so let's stop there and let's take a break. And it is 12:40. Let's come back at 12:55 my time. And we're going to talk briefly about prime, show commands, and some of this stuff I have already showed you. And we're going to get into prime, where to find information in prime. And then we'll get into client troubleshooting. All right, so let's be back at 12:55.